Good morning, students. So I'm Kayalvizhi. So today we will discuss about the file sharing and file protection. So first we'll start with the file sharing. So file sharing is a concept of sharing the files between multiple users. So sharing can be done through protection schemes. Like in a distributed systems, files may be shared across a network. So commonly we will use a network file system, which is used in the distributed file sharing methods. So any user may have a user ID. So user ID is nothing but the identification of a user. Say what is the permission they are going to get, and the protections can be provided per the user. So group IDs are there, which will try to club multiple users into a single group and then giving a permission for the groups so that they can get the access rights. So you can try to give a permission for a files or a directories also. Similarly, the group IDs can also have a access permissions for a file or a directories. So when suppose a file is going to be remotely accessed, then we will move on to the remote file access system. So manually the users are in a network to allow a particular file accessing between multiple systems. So manually we will use a FTP protocol in order to share the files. So if we consider the client server model, client to mount with the remote file systems which may be reside in a server. So server can be in a position to serve multiple clients. A clients are nothing but a user on a client identification that may be in a insecure channel. So they in a Unix platform in general, it is called as a NFS. It's nothing but a network file system. It's a standard commonly used in the Unix client server file sharing. So this is one of the protocol used in a Unix platform. Similarly, in a Windows platform, we are going to use a common internet file system, CFS. In a distributed environment, that is in a DNS server, generally we will name it as a distributed information system. It will try to use protocols like LDAP, DNS, NIS, etc. So while sharing a files, a common file thing is nothing but the failurities. So all the files when you are trying to share, we need to there is a expected possibility is nothing but the corruption of a file. So which means that either file may be deleted or maybe it may be accessed by unauthorized users. So that basic is nothing but the metadata. So we need to tell whether the file is properly exist or not, whether it is protected, restricted, or whatever it might be. And when you try to control a file in a remote, we need to concentrate on new failure modes. The thing is network failurities and server failurity. So these two are the yet another possibilities or happen in a remote file system. And recovery from failures, we can involve state informations about status of each remote request. So the stateless protocol such as NFS version 3, which includes all the informations about the request, allowing easy recovery and the restrictions, but it is in a less security. So the file protection, the file owner can try to give a control among the users. So to whom you can give to whom you want to give a permissions, or to whom, by whom. So that and all you need to define it. So for that only we are moving for the access permissions. So there are some different types of access protections, which is the read, write, execute, append, delete, and list. So read, basically it's only a read only method, read only mode, sorry. So if it is a write, by default you are giving a read as well as write. If it is a execute, you are allowing a user to read, write as well as, if you want, you can give a execute permission. And append, so which means that when you want to add some more information, modification permission can be included in through the append access. And in the delete permission, when suppose a user want to delete a file, you can permit them for delete control. And the list, which will try to provide you a just view option. Okay, so these 6 different access permissions are possible in a Windows. Say for an example, in a Unix, we have only 3 access modes, which is the read, write and execute. So 3 classes of users in a Unix or a Linux are nothing but user access, group access and public access, which may be others. So owner access, there are 3 digits which infers R, W, X, read, write and execute. So say if it is an example, binary value for an 7 is 111, so which means read, write, execute. So a owner will have a read, write and execute permission. Say a group access, if I give 6, it means that binary value for 6 is 110. So the read is 1, write is 1 and execute is 0. So which means that the group access doesn't have a execution permission. And finally public access, so which means that other users, say if it is 1 as the digit, then binary value is nothing but 001. So which means that the public access don't have a read as well as write permission, they have only a execution permission. So in that way we can try to give a access permissions in a Unix or a Linux platform. So say for an example, if I want to give a permission for a game file, the ch mode, that is change modification permission for the owner, group and public. So I can give 761. The file name here is game. So for the game file, I will give, for the owner they have full rights, for the group user they have only read and write, for the public they will have only execute permission. Okay, suppose if I want to go for creating a group user, then say for an example, G is the group name. So now I can add some of the users into a group and then you can give a permission. So for creating a group, you can give a ch group G name, so that the game file may be included into the group name called G, so that they will have a subdirectory on it, so that they can have a permission of 761. So this is the example for, that is the snapshot taken from the Windows platform. So say for an example, guest is chosen here. So in the permission list, you can see the full control is there, modify, read and execute, read, write and special permissions. So if you make you the allow or deny, you can say that whether this guest can have that control or not. So in this example, all the permissions are denied. Suppose if you select the allow permission, it may be modified. You can understand the file concept. This is the simple example of a snapshot which is taken from the Unix directory. So see the first line, which infers hyphen rw hyphen rw hyphen rw hyphen. So this is the particular file information. When we give a list command, you can see this ls hyphen a. Then you can see all the permissions of a particular file. So say for an example, intro.ps is the file name. So for this file name, the first digit is nothing but the hyphen, which means that this is a file. If it is a D, it means that it is a directory. So the second line, you can see there is a D, which means that the private is nothing but the folder. It's not a file. Okay. So for the first line, it's hyphen, it indicates the file, and then rw hyphen indicates that is the permission given for the owner, and then the remaining 3 digit infers the group user, which is the read write. They don't have a execution permission. And then R hyphen hyphen indicates the third last 3 digit indicates that it is a other users, that is the public user. So they have only the read permission. So in that way we can try to provide the access permission for a particular file or for a directory. Hope you can understand.